Hello,
Okay,
everyone.
we're
Thank you.
ready to go. Yeah, there you go,
Okay.
President.
Thank you, Christopher. Uh, and Emmanuel, we had a wonderful discussion
Oh
about
yeah.
my recent research. Early universe. I think we hit it off like it was like almost like 2 weeks ago or something. And luckily, Emmanuel was there. I also believe in him. He is a critic, but he is very smart in in pointing out, and he has done experiments. But I had long association with Christopher, and that's what made this text so successful. And I thank Christopher to be because a lot of time only we two are here, and then we continued our conversation, and we had debates, a lot of debate discussion. We didn't agree on many points, but then we found a proper way of agreeing. And I believe scientific things had to come like that. I mean, it doesn't come like people agree on every point and go on. That's not
Yeah.
science. So that's good. So always, sometimes you feel pretty bad that what's going on, and some other people had misgivings about these because they take it personally. And but we moved on, and we were not sure when we started because Christopher only suggested that I was maybe 10 years ago or more. I wanted to do in person one. I thought that will kick off the thing, but then we got financial things. So Christopher came out and said that why did we start this process, the YouTube thing? So he did that, and he is in charge of that. So we have been successful. We have been going for years together. I didn't realize. I mean, many of them actually go on, but they kind of fizzle out. But somehow we carried on, and we had a lot of excellent um, speakers, scientists who had a
And
new way of
more coming
thinking
up
and
as well.
original. Yeah.
We've got
So
more on the way. Like it's not a yeah, it's good.
yeah. So what it led to that is that, um, and I will get to the conference pretty soon, the Budapest conference. But my research, uh, you know, concentrated on figuring out one by one how the universe started. So there are a lot of debates about that, whether there was a big bang or not, or how it started. So which means that you need a higher theory that will look into these things. And I always have believed that. What is the bottom line we can go to? And I believe that if you look at the energy, you have, the big things now are the dark matter, dark energy, right? To account for all these things. But what was there before the whole universe started, if at all that was the case? And we are reason to believe there was some kind of a start because I myself am not born. So who am I before I was born? And suddenly I came to being. Of course, you know, our biogenesis is specifically through certain processes. But Darwin's evolution theory, things like that about human. So was there a life, or the life started as an inorganic thing? The universe was an inorganic thing, or was it organic? These are the questions that really mind-boggling to scientists. Nobody is able to figure out. And myself, I went through that. I have a background metaphysics, some deeper thinking I had, and I have gone into you know those situations where you start connecting with somebody who is telling you these things. So I had a fairly good success in that. But the final question is, can you prove it? The physics requires proof. And one of the things we are looking in the other group is just that. There are things I have experienced science cannot explain, the supernatural phenomena. But the physics requires specific law, like the thermodynamics, specific law, conservation of energy. This has been established. Uh, so we have to pertain to that science aspect. And people have thought about this. I mean, this was going on from Greece, the time of Greek and Roman empires. This was going on, and there were top scientists that we are following have come up with the thing. So it's very very deep thought processes, and they come up with certain rules by which are the laws. by which the nature operates. And then Newton came and that's developed the theory, the three laws, and that eventually that became a classical mechanics with when Maxwell came and they said, okay, how do you explain the light, the connection between the light and electromagnetic waves? So and he came up with a beautiful equation. Even now, that's one of the most beautiful equations ever. But then Einstein came and then removed all that and said talked about space time. So then you have quantum mechanics and to explain the ultraviolet catastrophe, things like that. So if you put all these together, these are kind of inputs you have. So, so I said based on that, what
Okay, yeah.
how do you
So
come up with
Rajan,
mechanics?
just that's a good overview then of the where have I gone? Oh yeah,
Okay.
hang
So
on. I'll minimize. Oh yeah, so that's a good overview. So I think you're. Am I right now in thinking you're moving into your research?
yeah, yeah, yeah.
So because what was it? The last day that we were on, Emmanuel was here and yourself,
Right.
and what you did you presented your research into this cosmology thing with the dark matter and the dark energy, and more importantly, this sort of baryogenesis idea based on seed particles. And I think the interesting thing about it was that it had what's the word? You had like quantifiable,
Mhm.
you had actual values, and you were making. I don't know if you're making predictions, but you were definitely making equations showing how much energy would come out of it, which is basically a prediction, I guess. So yeah, but I remember before that, I think there was well, yeah. So if we look at, we might as well look at some of the videos that we did over the year. That'll probably be a good focus for us if that's what we're doing on the. Should I share entire screen? Yeah, why not? Okay, so so you see how right there's all the live videos we did. Now I
Mhm.
think this video, which is just yourself and Emmanuel. I don't know where I was. You were having a chat on something anyway. I think it was kind of a general chat, but you were getting into this research of yours. Can you see
Mm.
this? Hello, hello.
Oh yes. Can you hear me?
Yeah, I can hear you now. So you're getting into this kind of
Oh,
research.
uh, Christopher, just excuse me. Something, I just have to attend to something. I'll come back in 2 minutes. This
No,
woodpecker is creating problem, so I have to drive it away. You know, we are having all these birds coming in, but I
no
will come
problem.
in a couple of minutes. Just
Okay,
2 minutes. Okay,
let's see if
thank you.
I can share this.
Oh, I am back. Thank you, Christopher. Yeah, I got it out. So, are you playing it?
Oh yeah, sorry. Are you back, Rajan?
Yeah, I'm back. Thank you.
Oh yeah, yeah. Sorry, I was
Yeah.
getting confused between your voice there and the voice on the screen.
Ah, okay,
So
okay,
if I go back to this, so the point
okay.
here that I was trying to make was you
Uh-huh.
have all these equations here. Now,
Uh,
are these all part of the work that you showed the other day, or is this separate?
I think it was separate. Couldn't see. Let me check. Uh,
Because I mean, it looks fairly similar, but maybe it was an earlier version or something, or
Let me
I don't
look
know.
at my video. I don't know. I don't know.
You
Let me
see
look
this?
at my video. Yeah, that picture I can see. Oh, that's about a superluminal thing. So it is prior to this. It's not the same, but it is like initial phases of that.
Yeah.
The conceptual
Right. So
aspect.
you've developed it further in the paper, is that it?
Yeah, exactly.
Like all of
So
these
this what
equations are
ah
these still relevant, or well, I suppose a lot of these are fairly basic, well, not basic, but
basic.
standard
Yeah,
equations. So do you want
yeah.
to talk about
See,
this or anything,
yeah.
or is
Okay,
there a
yeah. That's
point?
the interesting thing. But
Yeah.
what I did was it's like a logic of 3, 2, 1, 0, right? So from here I went back and then said, okay, what created that? What created gravity? What created? So went back. That's why I started the early in the what I did the part one. The part two will contain some of this what we have discussed. So it is a you go backwards very carefully. So this is what
Yeah,
I
so
did.
that
So
is
I said,
interesting because
yeah,
you have your solution there for which is
yeah,
oh hang on a sec, you have your solution, I think is interesting. So the solution was kind of emerging out of material science, and then
hmm
you you posit a seed particle, and I think I was asking the question about um, well, what is the seed particle? And your explanation was that it's this magnetic field. Um, but the one question I have then is why is it just like why settle on a magnetic field? Because couldn't it be like anything? Like you have innumerable opportunities to choose from, or maybe three anyway. It could be strong force, weak force, could be like a static charge. It could be, do you know what I mean? Like you could say, oh, it's dark matter. You could say, well, it's dark energy. It seems like you could like what is there any quantitative reason that would lead you to suspect that you're on the right track or anything like
yeah,
that?
yeah. Excellent question. So I don't want to talk about builder yet, but the thing is that I do agree some of the things he's saying that you have a physical mechanism. I believe that you have to have a physical mechanism that will explain. Like Higgs mechanism is there, but I think you need something even before that, even before Higgs mechanism. Because
Uh-huh.
I believe in mechanism because I studied that like in real, like environmental science, corrosion. Uh, I believe in mechanism. That's what I concentrated on, and many people agree that you have to find a mechanism by which something happens. You know, so what was the mechanism that kick-started the universe, for example? It's a very simple way of looking at it. But of course, there's one question behind that. Was there ever like a kickstart, like a big bang, ever occurred? We can always ask that question. But
Yeah.
that's why we have to go very, very one step at a time, very carefully backwards. And then we use a higher theory. And then that higher theory, we look at it and see whether that makes sense. So you need proper formalism, mathematics. And I agree with, if you watch, one of the things that got me inspired was I watched The Theory of Everything with the Hawkins, right? In that movie, his people, I think his bosses, so to say, in England, said that he argued, walking a wonderful argument about this thing. But they said that it's like your thesis advice or my thesis advice or whatever, somebody like that. They looked at into it and they were very sharp people, right? And they said that yes, but you need a formalism to prove those things. So that stuck to me that you need some kind of a formalism to prove whatever your hypothesis is or concept is. A lot of times I believe in experiments because I started an experimental material scientist, right? So experiments have to prove, but can we prove everything by experiments? Are there something that you cannot be proved by experiments? So these things started, going through my mind. And if we can come up with like string theory is, the most beautiful mathematical theory, but it cannot prove anything,
Okay,
realistically.
but just
So that,
going
yeah,
going back to your work then, and just maybe answering the question in a sort of a concise way. I think, what are you
yeah.
saying? Are you saying that there is a way to do this, or is it there's no way to do this?
There's a way to do it theoretically.
Okay.
Uh,
Well, what is
that
the what is that way,
consistency.
or have
Yeah.
you
So
already
correct.
achieved that,
Yeah.
or what? Okay.
Yeah. The main thing is what we see is the baryons or the protons are the most stable particle. That everybody agrees with that. The hydrogen, which was my area, but I studied the material side, so I know
Mm-hmm.
about hydrogen very well. Uh, that was my favorite. My professor is called the hydrogen boss of the hydrogen people because, but we are studying the materials aspect. So if you look at the star, everything, the fuel is the hydrogen, and the isotopes of the hydrogen creates that process by which you get the whole thing, right? All the solar things and energies that fuels the whole universe. So it has to be stable. The proton or the baryon had to be stable. So was there a baryogenesis? Was there something, what started the process of baryogenesis? That's what I look at because if you look at one of the things you see the evolution.
So
So there is
just for anyone watching this, can you define a baryon? You talking about boson,
yeah,
like non?
baryon is a more general way of looking at like a proton is a baryon. Uh, and I believe more in the proton, the baryon, but we have to talk about the real matter. The real matter consists of baryons. Uh, so what you call the symmetry. If you look at the symmetry and asymmetry aspects, you cannot explain because all the standard model, everything came up with annihilators and creators, right? Positron, electron, things like that. But
Uh-huh.
if you put all of that in the symmetry, nothing can exist. So what really created asymmetry? That's so it's called the baryon asymmetry, which
Yeah.
means that the however that area is still very gray area. That
Uh-huh.
was there like a positron and electron thing initially to start with,
Uh-huh.
and then the positrons somehow become protons and they became stable, and something that created a symmetry, is called a baryon asymmetry that made protons more stable, and that became the
Yeah, but
nucleus,
that
and
all
then the
seems
electrons
like
start going
that
around.
all seems to be after the point, doesn't it? Because you're talking about
Yeah,
some sort of seed particle generating
yeah, yeah,
so those could be protons or protons.
yeah,
So we're even before that.
yeah.
And the question I asked was just why settle on electromagnetic fields? Are there not other options? That's all I'm asking. Just simple.
Oh, okay. It's an excellent question. So the question about electromagnetic field or the light versus gravity. Since gravity is the opposite thing, right? Versus the electromagnetism. I think that these are the two big ones. If you understand that, I think we can figure out everything else. Seems
Yeah,
like.
yeah, yeah. Fair enough.
Okay? You can do the strong theory is part of if you put them together, you get strong theory or the weak theory. You can get that. Some the
Oh
weak
well,
theory has
yeah. I
been
mean,
proved.
yeah. I'm not sure, but Okay, I'll go with the first point anyway. Let's say electromagnetism and gravity. That's so really you've only
Not for the
got
big
two
guy.
options. So you're saying
Yeah,
if you want to create the gravity, you just use the electromagnetism. Simple as that. Is that it?
that's yeah.
Okay.
Which
Well,
one
so
occurred
is
first?
there any what
Which one
was there
occurred
any
first?
other?
The
Sorry,
gravity?
sorry, we're
Yeah,
talking over each other here. Was there
no
any
problem.
other points you wanted to make there, Rajan? Also,
Yeah,
I wanted to just know if was there anything over the year that you felt you'd gotten wrong that you had to change in your
yeah.
research that you'd like to
Thank you. Yeah. If you look at the other side of it, one of the things I changed initially when I started, it was an idealistic way of looking at it. I said believe in absolute genesis. There was nothing, and something started. This is the idea of absolute genesis.
Yeah, yeah.
But when I look at the physics over the years,
Mm,
there has to be something, the energy balance. If you look at it, I still think that that's a wonderful thing because that helps me to reset my mind the proper way. And from the point of view of metaphysics, everything, absolute genesis is a beautiful thing, like the string theory. But the thing is that the absolute genesis means that I have an equation where the signal is a function of noise, and I'm developing that also. See, the function is a zeta function, like a Riemann type zeta function. You can say that you can create a signal out of noise. Okay, that's way down the line. But the idea is that so there has to be a noise to start with,
mm,
and that kind of falls, kind of a contradiction to absolute thing that there wasn't anything in the world somehow. So who created that? Somehow
mm,
everything came into being, right?
mm,
Was nothing, absolutely nothing. Boom, something came into being.
mm.
you know, we call
Yeah.
it God. We call it. So that was there's a missing point. The physics, the physical mechanism, something will not allow that. You have to explain that aspect. We
Mm.
believe in that
Well, have you
strongly. The
considered
material aspect.
Sorry, Rajan, to interrupt. Have you because what you're talking about there, you've noise, and then out of chaos comes order,
Yeah,
essentially,
yeah,
and
yeah.
that's very interesting. I mean, have you considered within the maybe you could call it an analogy or something like that? We have this concept. What's the concept? Generative AI, particularly to do with
Uh,
Fusion AI. So how the image generation works, I'm sure you're aware of
uh,
this in AI, is you start with just noise. The image is just noisy, and then the AI actually begins to subtract a little bit of noise based on the prompt you give it. And so if you say like a picture of a church, it will
mhm,
subtract and keep subtracting the noise bit by bit on not in an area, but just reduce the entire noise until it
mhm,
hallucinates the image of a church from that noise. So I'm not saying take that process directly, but
mhm.
something you're saying some process like that is taking place to generate reality. Is that it?
Yes, yes.
Very
So
interesting.
I still believe, yeah, I believe in AI. I think you know it probably will solve at least. I mean, humans have to come eventually. But what you are describing is, I believe in the images because some images stuck with me, right? People talking, and the image doesn't change. Why it doesn't change? So I think AI probably will be able to answer this question. I mean, that's my
Right,
persistent
exactly.
problem.
But I mean, on another level, actually, it kind of does already answer it, doesn't it? Because if
Yeah,
we're saying the AI is hallucinating the image out of the noise, then in a sense, that's your answer, isn't it? The
yeah,
universe is
yeah,
an hallucination
yeah.
from noise. So, is there anything we can do with that? I mean, that just sounds like we're going back to shamanism. We're all tripped out
Yeah,
on
I
mushrooms.
I think that's why this formalism is important. What I said was You have to prove, we look at the math, and the math says that, yes, I need a superluminal condensate. Of course, that's the main thing. So everything was chaotic, but there was, in the mechanism, there has to be something that created this energy and things like that. Those are
Mm,
the monopoles. The monopoles are chaotically going. And they have it has been proven by even kinetic field theory that the monopoles are required and they have such large amount of energy in them that that is a violation of the Gauss theorem. You know,
mm.
much like the violation of Bell's theorem. I think it started with the violation because all the people. I mean, that's another topic altogether: philosophy and the logic and things like that. If you look at them, what they look at is the conjugate logic. The logic you cannot solve, so you look at the conjugate logic. For example, Gauss looked at the other side and said that, okay, the monopoles, and then there is a Maxwell equation. I also
Okay, so
modified the Maxwell
I
equation.
think would it
The
be
mo- uh,
would it be fair, just so that I understand what you're talking about?
yeah,
The question I asked was about what was the question I asked?
about noise.
No, no, it was about
The
hallucination.
image and the noise. Can
I
we
mean,
go back to
are you
image?
like when I ask a question, are you saying, are you in your head thinking, oh, okay, so he's asking about this, and then I'm going to answer this, or do you just forget what I asked and
Okay,
just
you can ask the question again. That's fine.
right? Because I might as well just be talking to myself, if you're not going to answer a question.
No, no.
The question I'm asking is it. Like I mean, I can just I can take what you're saying and answer the question. So
Yeah.
the idea was you have this hallucination out of the noise,
Uh-huh.
but
Uh-huh.
then so I was asking, so is that the explanation? Then we're all just tripping out on reality. But then you say, no, you've got the noise, but it's got like the superluminal aspect, it's got monopoles. So it
Yeah.
has so the noise has rules. So that
Yeah.
and it has structure even before we start hallucinating
Hmm.
whatever structure we currently view in
Yeah.
reality, which is like less than superluminal. But then that's a problem for your theory, then I think, Rajan. And I'm not asking you to solve it now because I don't think you'll be able to.
Yeah. I
But
mean,
wait a second,
yeah.
I have to
Sure. Go
say what
ahead.
the
Yeah.
problem is. The problem is that you already have structure, you already have rules. So it's not reality out of chaos. You already have an order implicit in the chaos, which is interesting. But so you don't have a solution. You're going down. It's turtles all the way down. We haven't reached the bottom, and that's fine. You're not going to reach it uh, with that method, I don't think. But it is interesting, and I like it. So, but there's another issue. I think in terms of problems with I think was it the last live stream, last TEGS live stream we did. Um, we spoke about something called which is we were talking about the PDP circuit, and
Hmm.
initially it's a circuit which goes bit of magnetism goes to the positron, let's say, goes to electricity, goes to the to the electron, and then back. So that's a circuit. So that's why you called it the PDP circuit. But then we dug into that a bit more, and you said no, it's no longer that. We're dealing with basically like an axis. So you would have to you probably have to rename that to the PDP axis, I would say, just to be clear. But I have another issue with that because you gave an explanation of what this axis is. So you have electricity here, magnetism here, and then orthogonal to that, I think you have the electron and the positron. Now, the problem I have with this is that you maybe have like the monopole here and the opposite monopole here, which is fine. But then, according to yourself and Emmanuel, the ends of those two monopoles join together to create the electron, or the positron, just depending on which way it's spinning or winding. And that's all fine. That's very good. But so it just seems to me that, you already have the two axes combined within this axis and within this one. So does that make it redundant or what?
Okay, yeah, excellent explanation, Christopher. So the idea is that, like I said, my idea is to go back and find the physical mechanism and connect to the simplest possible, like Occam's razor, simplest possible thing that we observe. So what all things is that the electric and magnetic fields are orthogonal to each other. This has been proved, uh, you know, beyond shadow of doubt, I believe, and that was the basis of Maxwell equation itself. So what are the ends of this electric field? What are the ends of this magnetic field? So can it be a discrete thing? Like if you go to the local level, ends of the, you have, if you have a monopoles, North Pole and South Pole, they automatically have a magnetic field between them that connects the North Pole and the South Pole. The
Oh,
same way,
that's
if you
right.
have positive,
Sorry. That is correct. I was mistaken. So it's not, it's the two end of the monopoles. It's not the electric and magnetic. It is the north and the south, the two
yeah,
monopoles. Yeah, that's kind of what I was getting at when they join together.
okay,
So,
okay,
so the point is that if you have x, like plus x and minus x, and
uh-huh,
then those two join together to create the electron, but the electron is plus y, let's say. So
uh-huh,
you get plus x minus x, and now you're getting plus y, or depending on if you go minus x plus x, you're gonna get
yeah,
minus y. But that doesn't make sense from just mathematically Cartesian coordinates. So there must be some other law that you're using. But I don't think, and certainly if you had it's certainly not going to be a circuit. So you might need to go back to the drawing board on that. But I think maybe it's not a total disaster or anything because, excuse me, you can do. I think what you're saying is that you're sort of working from a metaphysical point of view, but you want quantitative physics answers in there. So you're kind of
yeah,
you're working a bit on the edge of things, so it's a bit fuzzy. And I think since that is that's your mode of operating, you should be very untied to your ideas. Just so make sure that you keep moving, keep breaking them apart. Don't be precious over them because you're exploring on the fringes. So if you say, you're like divining some sort of conscious signal from like wherever.
mm-hmm,
You have to resolve that and understand what it's saying. And if you're too quick to say it is this way, then But the good thing is you can use logic to say, okay, the current structure doesn't make sense. I need a new one. So, but you can
mm-hmm,
don't throw out the entire structure. Just modify it in small ways until you get to something that's usable. But I really don't have the answer for that because that's your research. But I would say there is some interesting things. So recently, I had a weird sort of experience that I might as well
uh-huh, okay,
communicate. And so basically, I was listening to this weird podcast online, and they were talking about poltergeists and
yeah,
things of that nature. And I was like, well, isn't
okay,
that's an interesting idea? Because what is that? It's like a disembodied consciousness or something.
mm-hmm,
And anyway, as I was thinking about it, I heard this noise come from my bathroom. So I thought, that's a bit weird. So I went in and I looked, and normally you'd hear noises you don't bother investigating. But this time I did, and I noticed the two shampoo bottles that were in the corner of the room. There was nothing around them, they just fallen over on top of each other onto the ground. And I was like, what caused that? Maybe it was the this thing about a poltergeist. So I kind of moved my hand down towards them. And I could feel this electric static field.
mm-hmm,
So let's imagine that there is like a non-corporeal entity that is somehow capable of. Is this going to work? Maybe that's the wrong color. There we go. It's capable. It is. Hang on. Sorry about this. I don't know. I do not know how to use this. Is that undo? Yeah. Thank God. It's somehow non-corporeal. So, and it consists of electric and magnetic charges arranged in some sort of grid like pattern, or let's say not grid because that's a bit a lattice, right? So this is my, so I'm just going to, instead of drawing them, I'll just do little dots. And then, so let's say it's like this. And then we have those are going to be the electric points. And then you'd have like magnetic charges going to each one back and forth. And so you have some sort of network set up, and it's kind of buzzing and vibrating. And much like our AI, artificial neural networks or whatever, they are solving a problem. So they're trying to get to the minimum error, or the minimum in their cost function. So they have it. They start off with just randomness, and then they keep back and forth, and they try everything out until they get to the answer they are looking for. Obviously, this process can't involve anything like electrons or positron pair creation in that sense, because as we know, that system is highly energetic. And if it was going on inside your body, for example, the runaway, there's the photons, and then you have a positron, and then it just keeps going, and it would be very deleterious or injurious to your health, correct? Causing all sorts of problems to the. So anyway, but we're talking about something that's lower energy than this kind of thing. And so then we have a lattice like this, and just go away. Right. And then, so let's say we were to rotate this, or let's say we were to say, instead of these diamond shapes, we were actually talking about nice circles. Okay. And so the circles are kind of what? They're kind of friendlier, aren't they? They're not as jagged, So this lattice would be jollier, maybe a bit slower. It wouldn't be as dynamic. It wouldn't be knocking over the shampoo bottles in your kitchen like a menace. But it would be, I don't know, maybe it could like clean your floor a bit, or like just sit and watch TV with you or something, So the point I'm making is that maybe there's some sort of geometric connection between different disembodied entities in the universe based on a lattice mode. And then, what use is that's the metaphysical part. And you can see how this would relate to your PDP circuit kind of thing. It's like positive, negatives, and charges, and all of that. So it's a bit of fun. And you've got a huge variety, because think of the amount of different patterns that exist. Patterns, I don't even know if this is going to be a worthwhile search, but images, I guess. I mean, there's just so many, and I'm assuming that in material science and so what I'm saying is that each of these has some sort of personality to it. So there's an infinite number of kind of personalities, and some of these could be even gods. And I'm sure, like in old religions, they're worshiping these things, and certainly if you're taking different kinds of mushrooms and stuff like that, you're going to see these patterns, and therefore, what's the point I'm trying to make there? Sorry. You can even imagine that if you have an AI that's hallucinating, if it starts hallucinating these kind of patterns and they have some meanings, then you could hallucinate a pattern beyond the pattern, which is informed by the pattern in some sense. That's a different issue. But going back to the more materials physics side of things, if we imagine like what are those things called where they do meta materials? So I think a lot of meta materials they're not looking at components so much, or they're looking at structure, aren't they? They're saying, well, let's structure the molecules on this wafer or whatever in a particular configuration, and then maybe pass a current through it and see what we get. So so the question is then, if you generate metamaterials with like a dynamic pattern versus metamaterials, well, they're all kind of dynamic, aren't they? Versus one with a more obscure pattern, or a bit of around a certain more circular pattern that's a bit gentler, will you get different effects? Could you start creating, for example, maybe apply this to AI and start creating noise based on the patterns that so you'd have AI with different personalities almost, that would, like, the AI would only hallucinate sort of beautiful pastoral scenes or something more, or it would, not that it would only do it, but it would be more inclined towards positive things, or maybe even just less dynamic things, lazier things, whereas something like this would be more inclined to hallucinate active, like, and then even towards the more negative things like war and such. Yeah, so that was just a thought I had. Oh, sorry, where are you gone? Back here. Now, so I think that kind of that kind of covers a lot. So if we're going to do this, we're going to look. What's the title of this live stream again? It is a
retrospective. Yeah.
So let's do that then. Let's go back and take a look. So all of these are in the last few weeks. So this is 2026. We've had some good ones towards the end of the year last year, particularly the physics decoding alien messages, 9/11, and locating alien UFO bases. That's good if you want to watch it, I would say. Interesting research. We've had Bill on the rope hypothesis. We did quaternion rotations and electromagnetism. That's okay. Needs more work probably. We already looked at this video. That's your research sort of and a discussion. Yeah, we can skip over these, I think. And so basically we get to the TEGS Budapest 2025 conference, which was really the biggest thing that happened all year, I would say. And a lot of that was done in conjunction with Laszlo, who was sort of the main person because he's based in Budapest. So that's all good. And then actually, if you look at it, the majority of what went on during that year was really preparation for that very conference. Yeah, so that's interesting. And we did a Vixra deep dive, which I don't think was very successful. And that's it. And that's kind of all we did. If you think about it, I think I was very busy because of the PhD, that I really wasn't, and setting up the conference with yourself and others. So if I was to discuss any of my own research over that period, I'm pretty sure. I mean, a big thing that well, you'll notice in previous years, it was all about this 120 cell theory of everything, and things like of that nature. Sorry, I've got a really dry throat here. So, okay, so things of that nature, and that really dropped off in 2025 because I went more into the anamorphic perspective cosmology, which, as you know, is the hyperspheric model. And we'll get back to that. shortly. But the main thing was that I stopped kind of looking into this more geometric 24 cell up to 120 cell thing because I got a bit confused about the vertices of this object. I was placing, let's say, a right-handed electron here and a left-handed electron or positron there, and so forth. And then I realized that through later research that an electron, as it's moving through space, let's say, can be both right and left-handed at the same time. So this posed a problem because I was thinking of the weak, in the 24 cell model, I had the vertices of the 24 cell were matched to, I think they're 2x2 matrices. I got to be careful here because sometimes I've made mistakes in the past calling them SL2C. I think they might be SU2 matrices because there's actually an infinite number of SU2 matrices. So sometimes there could be some of the terminology I used in papers but might be wrong. I don't think because SL2C is different. So, but you can convert between the two, I think. Okay, so the point I'm trying, and then you can take those SU2 matrices and use them to permutate coordinates, which then become like a little box with 8 different squares in it. And so that becomes an S8, like a symmetric group 8 permutation. And the interesting thing about these permutations is that some of them are disjoint and some of them aren't, right? So the disjoint ones just go back and forth, and the non-disjoint ones or continuous ones will create a circuit. So it's more like kind of like a Lagrangian, but that's not really an issue. But the thing was, we could use that. I don't know if I have a paper on that might help visualize this more succinctly. So we can use these instead of saying, well, a plus vertex is a matter particle and a minus vertex is a antimatter particle, as you might expect to do. Once you apply this S8 symmetric group, you find that all of that kind of goes out the window, and the vertices are no longer assigned based on their sign value. Rather, the particle and antimatter particles get mixed up in that sense. They no longer, conform to those kind of simple rules, but it becomes more complex, as you can see here. So if you have a non-disjoint S8 matrix, I've forgotten what they're referred to. There's a specific name for them. Directed graph, because they're a directed graph. You see here the arrows go like to the left mainly. Or you could reverse this and say they go to the right. But here they go neither to the right or to the left because they cancel out because they're disjoint. So if you were to say, well, this is a left-handed particle then, and then its opposite would be, so that's why we get the left-handed. But, and this may be wrong actually, because I'm saying that it's left-handed antimatter, but I think it might be left-handed matter. So I might have to change that. So this binds to the weak force, but this doesn't, because this doesn't have a handedness, you see? So then you can arrange everything that way. And so initially I was thinking that I'd made an error because there was no such thing as a particle that was purely left-handed or purely right-handed. Do you get what I'm saying? But because of how the Higgs mechanism or electroweak symmetry breaking is formulated, it's all fine because you're dealing with these kind of things, like vectors with the particles already in place, and it's just perfectly valid to do it. Although it does get a little bit confusing just trying to keep track of all of these things. So the point I'm making is that this became kind of back on the menu as a valid sort of point of research. I could return to it and expand upon it a little bit.
Excuse me,
Yeah,
Christopher. So maybe you can explain. Most people are aware of it. The difference between left-handed and right-handed. Is it
yeah,
based on the mirror symmetry, or it is based on something else? Because I always wonder about those things. Why
yeah, yeah.
there are no one of them is there, the other one is not there. So maybe you can throw some light into that. If you can.
Well, what I'm trying to say when we talk about the left-handed and the right-handed thing, I mean, if we're looking at particles, we've got things like charge. That obviously relates to the matter antimatter thing. Then we have spin, obviously, up or down, and then we have the final, not the final. Well, one of the other major aspects of the particle is its chirality, which can either be left-handed or it can be right-handed. And then so that goes all into the mix, back into the mix with charges and such. And it's to do with what direction it appears to be spinning relative to the direction of its motion, I believe. And so but it can, it can have both phases. It can be like 50% right-handed and 50% left-handed, which means it's in a superposition of such a chirality. But it could be 80% and 20%. So the ratios could change, and they're apparently pretty random, and they're happening, in a random way, like as you'd expect in quantum mechanics to occur. But the interesting thing is, so let's say we have this broken symmetry of the weak force, and it's binding to a particle. So let's say you say, well, this is a right-handed particle in space, or this is a left-handed matter particle, and this is a right-handed matter particle. Well, there is no such thing technically, but we're saying that the weak force only binds to let's say the left-handed side of the matter particle, but not the right-handed part, and so that is the main issue here. And so that's kind of it is interesting that you can relate that to S6 S8 matrices and do it that way, and you can actually incorporate them then into the electroweak symmetry breaking mathematics used in the Higgs mechanism, all the way up to the point where you diagonalize the matrix to get the mass side out of it. And actually, that's a good point. I don't know if you saw all of this research that I've done using AI. I've been meaning to
Some
share
of it,
that.
yeah.
Yeah.
I think some of it we went through. And are you
Mm.
saying is it connected to parity, this chirality?
Oh, yeah, because there is that parity. See, that's the interesting thing, Rajan, with parity, and wasn't there was research done into that with the weak force, and so they would have they were looking at beta decay, and
Mhm.
and so basically what they found was something to do with the symmetry when you if you're talking about what is right-handed and what is left-handed, usually that can depend on which direction you're facing. Because like if I'm facing this direction, I say that's to the right. But if I turn around, my right is now my left, kind of thing. So if you were trying to communicate to an alien species the concept of left and the concept of right, one way to do it would be through this process of beta decay, because no matter what direction the particle is facing in space, it will always have like the left spin if it's a matter particle, or the right spin if it's the antimatter particle. So I believe you're correct. Yeah, the mirror universe because what do you have? Charge, parity, and time.
Yeah,
So
time reversal. But
yeah, and it's a reversal thing, right? So we're talking about at the quantum level, you have time irreversibility. people are trying to bring that in on a macro level as well. But certainly, charge is down there in the quantum world, and so unless I'm mistaken, I would think that parity could refer to chirality, but then why not just
Mhm.
say chirality? I think parity might even be a wider subject. If that might be something you'd have to look into yourself, Rajan. Uh, yeah, unless you have.
Oh yeah, I see. Yeah. I have like 2 or 3 papers coming up. After that, I will go back because just to finish this train of thought right now, my paper, in the next paper, I talk about how the time can be reversible
Mm,
in the and I go into detail about that, and then how the time becomes irreversible, the macroscopic level. So that's the first current paper that's going on. And then I will go back uh, you know, again to the idea, the next level of the fun we are talking about, the supernumerary seeding, and that created baryons, and then how that created a lattice type hadron lattice, and that stabilized the whole thing, everything, and then
right. Mm,
gravity came to be. So after that, I will look into your. All these are very interesting. So I'll go back
great.
this
Yeah.
video.
You see, I have a lot of work here that I got. We have the Lagrangian. This is the Yang-Mills Lagrangian and stuff of this nature. I'm just looking at it, going, yeah, that looks okay. uh, uh,
Mhm.
all of this, it's all pretty standard stuff. I think. I mean, I haven't really gone. I was more just like, it looks good. I haven't really. And then you get to this kind of thing where you know, it's just this plus that. So and then plus a mix, which I'm not. So there's a few things that I need to go through to make sure that they're correct. Um, but it's all pretty good. I mean, I think this diagram kind of shows the idea in a fairly straightforward manner. Might be a bit too much to go into here, but I'll give it a shot. So if we have, how you could have plus and like two like charges attract, or no, repel, sorry, and
Oh
two,
yeah.
yeah, so two positively charged things might attract, two negative or repel, two negatively things might repel, but then the mix would attract. So this would be, if you like, you could say this is -1 because you have repulsion, -1 and one. But then with gravity, two two bodies that both have like a negative field will attract, because gravity is
Mhm.
a negative force. But then if you had an anti-gravity field, that would be a positive field, obviously, but then they would also attract. So here we have one and one on the outside. And then if you had a mix between gravity and anti-gravity, you're going to get minus and minus. So we have now these two vectors which are opposite each other. And so you could rotate using SO4 or an internal rotation to take this group to that group. And so this is the surface tension gravity idea. So we're allowing for anti-gravity as a concept here. And then we rotate into the static electricity, the way you have two static charges attract. And then you can, sorry about this. Wait a second, I'll get back. So you can rotate into the two, and that will be a thing. Hang on. Oh yeah. So, sorry, are you still there, Rajan? Oh, you are.
Yeah, yeah.
Okay.
Go ahead.
Okay.
You have a
So
question? You're
yeah, and
asking
then
me something, or
you can vectorize all of this, and then it creates a field. And then what you could do is combine the two into like
uh,
an 8 vector to create QCD. So that's like essentially
so
SU3.
I want to know. Normally, we can use a generator, right? SU2 and U of 1, standard generators. Can we use them as standard generators to create other things?
Right,
SU2?
so that's in the standard model for mainly with the what's the thing called? The weak thing.
Yeah.
Yeah, I mean, you can do that.
But you cannot create a SU3 from operating SU2 and a U1. Can you? No.
How do you mean?
Can you create a SU3 by operating SU2 and U of 1? Can you do that? Or they are separate? Because normally it is U of 1, SU2, and SU3, right? You need that for those are the minimal things you need for the standard model
Yeah, you see, that's the
create.
interesting thing, because you talk about these gauge fields and one
Yeah,
thing
yeah.
mixing into the other, and then say, oh well, like we've unified this field with that field, but apparently, these quantum physicists aren't very happy with such unifications because it's a mixing field. It's not like a single, like let's say an SU5 that unifies all
Mhm.
fields into one um, group. But here because this is a kind of a strange thing because if you have like a gravitational field here, that's like already a three-dimensional space. So and then over here you've got another maybe U1 field or something, and then you're moving all of these into all of these. So we're if you want to take a say that this is a real rotation through 4D space, that would be wrong. So I think saying this is SO4 is wrong. You'd probably want to do more of a maybe an internal rotation, which is kind of what happens here anyway in the SU3. So you just combine, so then you're just combining these two vectors into a single vector. So then you could imagine that, these are the different gluons that can be rotated in space, but, this one would link to this particle. So that, or not this, sorry, this slot within the four vector, not the, I'm not, I shouldn't say four vector. I just mean a vector with four uh, uh, slots in it. And so if this is like EM and it's turning into a surface tension gravity component, and then same going with all of these, then these are going to switch in like different ways, and it puts certain restrictions on how that occurs. But it's more of a sector kind of thing. If it gets to a certain point, it just automatically switches to a different um, value in space. So I think that's what this says. I have to go back. But so there is like a full Lagrangian, and so I was considering this unification theory. Obviously, there's some sort of stipulation about that, but you can go on and unify the electric part out of this back to the weak symmetry breaking and Higgs, and then also to we take Higgs as a spin zero. We have a spin zero field here, so you can unify it that way, and that kind of so this is like a unification architecture, and you could even as we said before, we can unify this 8 vector back into the S8 symmetry breaking here, just in a light way, and that's kind of it. But I think maybe a bigger a potentially more accurate, no, maybe that's the wrong word, um, unification method might come from this with the modified particle model standard model particle, sorry, using the 24 cell, because here we do have something that we can relate the vertices of the 24 cell through a kind of algorithmic approach to arrive at S4. Now, S4 is obviously the symmetric group 4, which is not continuous. It's a discrete group. So if I was to say, okay, I have all the particles on the vertices in the 24 cell, and then I have this S4, isomorphism, if you like, or whatever. It's not really an isomorphism, it's something else. Unification layer between the two. that's pretty good. But and then I say, well, based on all of the logic laid out here, we can then start generating different braids for the different particles, and then look at through the rope, or not. Well, it's kind of a rope model, if you like, a different version of it. We can say that they interact and cause annihilation and such. And then we can even have force carriers with the photons mediating in between. And then we have no problem anymore with the blow up at the singularity point. We can just smoothly integrate over this, and that's like, so we don't have to think of this as a discrete thing anymore. You can see how in some cases here, like with this orange line, it's discrete, but then it's continuous here. So if we just said, well, this is a continuous wave function, and put in like a wave function here instead of a discrete. So we just say, so that's kind of what we do. We're just sampling discrete points along an actual continuous wave function. So I'm not sure what that group is, though. Some sort of continuous S4 permutation group. And I'm saying that is the unifying sort of structure for all the forces in a sense. I'm pretty sure that if I was to say that to maybe a quantum physicist, they would disagree strongly with that. But anyway, I just like it. It's like a game, it's like kind of a ring structure, and it's fun. We can also use it effectively to get actual values for interactions, because we can take discrete measurements and get actual quantitative results out of it, as you can see here, because the basic structure of this entire concept then becomes this thing called a plectomeme. This is a plectoneme, where you have a twisted cord, and then when you pull the edges, because of the tension in the cord, it just winds up again. And then,
Is it like a king? Is it like a king or something like that?
like a
Or
what?
loop king? King. K-I-N-K. King.
Yeah. Actually, because there is it's called, there's a number of different words related to it. Supercoiling is another one. Something you'll see a lot in DNA and the study of genetics. Supercoiling, and then there's this thing called Hockling, where the basically, like if you were to take the plectomeme and pull it again, it's going to go back to this sort of Hockling, which is what if you're trying to make ropes, you're trying to avoid that, because it would be like a kink in a sense. So you don't want that. So
yeah,
you could think of it as a super coiling, or a super Hockling or whatever.
You can actually see very easily. If you are like strings, you put them suddenly, they will start connecting. Maybe your surface tension, or you have the static friction, static
Yes.
electricity, right? That's
Yeah,
essentially
exactly.
making them do that.
Yeah, it's a fun concept. So right, was did I make the point I was trying to make? Yeah. So we have the plectonemes, and the particle interactions. Where was it going with that? You get the lanes, the supercoiling. It is interesting. Does it does it sort of unify? I think it's kind of an overlayer, rather than saying that this is going to go in and unify U1 with, because you have like this U1 cross SU2 cross SU3 or whatever. I don't think it's really doing that. I think it's sort of ignoring all of that in a way, or it's like on top of it, and so it's a unification layer that is effective. We also can, like I said, start getting real values out of it, because if we're talking about these these coils, and then we look at them as we can start getting wavelengths out of them, and then particular length scales, um, which we're measuring in like fractions of a centimeter, and then you can actually get Lagrangians out of that and get um, solutions with real units, so um, and that come out correct to experiments once they're scaled. So this is, again, all of this research is done using like ChatGPT 5. So I don't know if this is correct, if it hallucinated this. It did give the right answer. So that I'm going to have to check that. But this is just to say that, I would not have been able to create this by myself. I don't
Oh,
know.
the equation,
Yeah, no, I'm
period.
just being perfectly honest. I don't, the way you come up with these theories and then someone says, well, where's the Lagrangian for that or something? And then I'd be like, I don't know. How am I even
Yeah,
supposed to?
now you can get it done through the AI thing. Yeah,
So
Lagrangian,
the
all,
AI is
all this.
pretty good in that sense, isn't it? Like it'll come up with a Lagrangian, and then you can quantify it and get an answer. But is it correct? I have to
Yeah,
check
that's your
that.
tip.
Yeah.
Because if you are doing by yourself, right?
Mm.
You can actually work it out. I had done that earlier. Before AA was there, I used to work out the hard way. But
Yeah.
you have to
But
toil.
I
It
see the
takes,
problem, Rajan, is I don't even know the process to begin to work it out. So this is
yeah,
going to be fun because I now have something and I can kind of work backwards from it.
yeah,
And
okay,
yeah, so
yeah,
but I mean, it would be the same thing,
yeah,
like the way we've been talking to Bill. Like Bill has a
uh,
a structure, and it can like explain a lot of the same things that like normal physics ideas can explain, but it does it in a different way. And so the idea is that it's meant to give you more insight into how the universe operates if you're open to a different way of doing things. And also, we note that Bill like isn't really that interested in quantitative. He doesn't think it's a valid part of science, of physics, or whatever, and that's okay. But um, I'm not saying that I agree with that. I think it's maybe an extreme case, but I also think the opposite case is also extreme. Like if you're saying, well, great, you have your theory and your unified discrete, field theory, but where's your Lagrangian? Where's your quantitative stuff? Well, here it is, and but
well,
does this as a person then, like, let's say this is correct, and I know, does this, the fact that this exists now and that I have it, does that make me feel better about the theory? Do I now feel like, yeah, I've arrived? No, it doesn't. I actually see this kind of as a detail that was already sort of implicit within the entire model anyway, which is more like an abstraction, or more like what Bill would be saying is like, without the maths, with the maths. And you could belittle this and say, well, this is just a picture. But then you could also just belittle this and say, well, this is great, but it's kind of not that interesting. And you add them both together, do you get something stronger? Yeah, I think you do. And I think that is pretty interesting and cool. So maybe you need both, but
yeah.
uh,
It is like a model you have. The model is
yeah,
yours, right? Your own thought is creating the model, but then you need certify something to justify the model. That's where all the math and all comes in. But the model is yours. You have conceived that model, and that's the important part.
yeah, I
That's yours.
agree. So, and that's true of Bill's work as well. So I think people need to be a bit more. I don't know. Well, actually, I don't. I'm not even sure it's really that important. Like what opinions people have. Although it does come in. It does become a problem when you're talking about, let's say, trying to get reviewed for a journal. But who's
Oh
really
yeah,
doing that anyway? You know what I mean? Unless you're talking about funded research, you're not going to apply to any of these journals because they're just too expensive.
oh yeah. So that's one thing I have seen. And the journals I am working with, they eventually I improved, and I hope that eventually they'll get to a point they want to put that from previous is in archive. So I'm trying to find out
Oh,
there's
great.
somebody who can give you are archive.
You. So do you know someone who works in the arc or not works but is already published in a certain
Archive
area will be
manual
able to vouch for you? Because
Malabar. Malabar can get you, but I don't know. His
oh
country is in trouble, right, with the U.S. So there is a lot of,
oh is
but he does
Malaver over
reflect.
in Venezuela? I thought he was. I didn't realize he was in Venezuela.
Yeah, he's from Venezuela. He's a professor there.
Okay, right. Um, yeah, and there's trouble going on with Iran at the moment, isn't there? They're going to.
Yeah.
I think they could invade there in the next few days or weeks or whatever.
Yeah, yeah. It's very, very chaotic there.
Uh huh.
So
And then
I don't know.
what
There'll be a
was
regime change or anything like that. But yeah, it is a boiling point. It's come to a
yeah.
boiling point.
I think they want a regime change in Iran. They want to put the Shah back in, or the son of the Shah, or
Yeah,
something like that. So he was like the former king, or something like that. Anyway, so
we don't know. It's
it's going to be
complicated.
it could be interesting. I mean, developments. The same time, yeah. I suppose yeah. We'll see. So, and obviously, then in the US at the moment, you have a huge, big storm brewing, like a
Oh yeah,
literal storm this time.
it
The
will work.
snowstorm
But
coming in, and that's not affecting you over there. In
well, we
obviously,
had
you
off and
are in
on. The storms come as a result, but it's no. It is kind of mitigated by other things. So by the time it comes here, except for a few things, they become milder. So the
Okay.
desert does have a problem, like dust storm, things like that in summer. That's still a problem. But other things, somehow, there are mountains, other things. By the time come from California or from there, it get smoothened out or it get diluted.
Yeah.
That's so
Uh
we don't
huh.
get as much of a storm. But now the other areas are really getting pounded by snow and other things. So it could be some places very new. It has not happened in years or even decades. So
Well, yeah, because
inundated with
you essentially live in a desert, don't you, Rajan? So you wouldn't expect
yeah,
too much snow in that region of the world. But
yeah.
I'm sure
I mean,
it was
up in
occasional.
the north, there that place is one of the highest. Called Flagstaff. Uh, that place is one of the highest snowfalls. This year, of course, is El Nino. I mean, very, very mild. It is well below what is required. So people are
Hmm.
worried. Because you need snowpacks, to have fresh water. You need snowpacks. But there is not enough
I suppose it
created.
has to do with altitude. Then is it? Is it a very high altitude
Yeah,
area up there in Flagstaff?
yeah, yeah, Flagstaff. Yeah. Go up the
Okay, so
mountain. If you,
yeah. So just going back to the archive points, what I've taken to do is maybe I'm thinking about publishing those new papers, the AI research ones with Vixra, because Vixra is interesting. They or Vicra, I'm not sure. It's like archive backwards. Um, they have like an AI section of the journal where if your research used AI at any point, then it goes into there. And then they have another one which is like not
hmm,
where you didn't use AI, obviously, or large language models. So that's pretty cool because then you don't have to like constantly state, "Oh, this was made using
yeah,
whatever ChatGPT 5." You just
yeah,
load it into that journal or this one, and depending on what techniques you used, and that's good because you can get you get like references and such. You can reference your work, and it's stored there. So as an alternative to the archive, but yeah, at the same time, it would be cool to get something in the archive just for um, just for interest's sake. But I have to see. I'll have to. It depends whether someone's already published in it, whether they're going to accept sort of, what's the word, where they'll back your work and say, and then whether it's accepted by the archive again, and so all of those
Somebody put
factors.
in the, I don't know whether you saw in the research gate. I can pull up one. Somebody has asked whether you can look the archive. Can you? I saw it just today.
Oh,
One
yeah,
minute.
go ahead.
Yeah.
I'll have to
So
go.
let
I'll
me.
have to go
I can pull up that.
shortly, though,
Let,
Rajan.
let
I,
me
I
pull up
can't
that
say,
and show you.
yeah, show. But I can't stay too much longer. I have to get going.
Yeah. 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 No problem. Okay. So if you go here,
Yeah.
you see that seeking archive endorsement.
Oh.
Please doing that.
Yeah. Yeah.
Yeah. All you need is 30 seconds or something. He says you can do it if you have that.
What?
So yeah, he says somewhere seeking archive endorsement.
Oh, yeah.
So I have received official request, endorsement request. So
It
maybe,
only takes, like, yeah, according to him, it takes less than 30 seconds. Fair enough.
yeah.
Well, it does it though. You have to sit down and look at the person's work and decide, do I want to endorse this? Do I agree with it
Yeah.
even? Yeah. So there's all of those things. So that's really cool. I'll definitely look into it in the future, but like I say, it's not really that important. If you got Vikra,
Um,
I'm happy to just use that. I really don't care about,
well,
like,
I think this will increase as time goes on. I think the physical reviews start diluting effect, and these that's my projection that the other journals which are not this thing they will come up because they are really doing I mean the reviewers are good. I mean they do a good job.
for
So
sure.
I think that's a plus thing that's going on. So
Mhm.
I look at the reviewers itself. When they review, are they reading it? Are they understanding it? Are they critiquing? I think they're continuously they're improving higher and higher standards. So I wonder whether people are moved from physical review into these because original works are here. Where physical
Mhm.
review you need just to conform with either theory of relativity or quantum mechanics. If not, they
Mhm.
won't even consider like standard model, things like that.
Mhm.
If it doesn't
Yeah.
conform to that, they may not even take you to the next level, you know.
Although I
So
think
that
they're a business, though. It's a good question, Rajan, actually, because like they're a business, so they want to make money. That's what I think,
yeah,
and I think they make billions every year. Some of these big journals, like
yeah.
Nature and such. Certainly, wasn't Springer, but one of the big journals recently got delisted,
Oh,
Elsevier maybe, and
oh,
can't remember which one it was. Sorry. So if it wasn't Elsevier, I apologize. Yeah. So so the amount they earned for the year was released was something like 16 billion or something. I was surprised.
wow.
It was, but not
No,
that
that's a lot.
surprised. But so yeah. So I think there's two functions of these journals. One is, like you say, to control what's being spoken about, and then the other is to make money. So if there was a big enough shift where people were like, well, look, our models are broken, and we can see that because they don't match what we're seeing in the universe. So we need to change. And if that change was big enough that their level of control was just lost because people were saying, well, we need to move into new areas, but they're not going to move unless there's maybe funding there to move. But they're going to have
Yeah,
to move if the theory is wrong and it needs to be readjusted in some way, in a very significant way. Then yeah, the whole thing will be in a bit of turmoil. It should already be in turmoil. It is in turmoil, and hopefully, I don't
yeah,
even, this whole concept of your research isn't correct unless it's published in this journal is a logical fallacy, right? Because
yeah,
it's appeal to authority. It's genetic fallacy, meaning that this argument is correct or incorrect based on where it originated from, and So if we're dealing with physicists who are supposed to be logical and they can't even handle basic logic fallacies, then we have a very big problem, I think. But these people, like you say, are very accomplished, especially if they're working in academia and stuff, or and they're very good reviewers and they're very tough reviewers. And
Oh
that's
yeah,
all.
yeah.
But, yeah. So the question is, what's more important to these to the journals? Is it control or is it money? Or and both I think are hand in hand. It's
Yeah,
like
yeah.
lose a bit of control to gain more money, to use the money to gain more control.
Yeah. So it's just,
And back and forth. Yeah, so that's how they're going to function until they're no more, which I think should happen fairly soon. I mean, if you look at where did even half of these journals come from, or more than half, it was all that guy Robert Maxwell, wasn't it? His empire.
mm,
And who is Robert Maxwell? He was a media mogul. And who is his daughter? His daughter is Ghislaine Maxwell. And what is her empire based on? Well, pedophilia. So how does an empire or lineage that is, based on like human trafficking and child sex rings, and that lineage is based on like all of scientific research is being funneled through their empire. How is this okay? What I mean? Like think about the Catholic Church. He had a scandal there, was it 20, 40 years ago? And I would say if you spoke to a lot of physicists and scientists in general working in the field, what do you think about that? Oh, terrible. Do you think it was right that certain people stopped being Catholic because of that? Oh, definitely, atheism or whatever. And yet they're happy to publish in these papers, and it's proven that they're all part of some sort of child sex trafficking system through
yeah. Where the ethic,
connections.
where the
Yeah.
ethic, morality, it's
Yeah,
out the
where's the
door.
morality now? Yeah, they don't have any morality. It was all bullshit. So yeah, anyway, so that's my point. I'm gonna leave it there, Rajan. Thanks
Sure.
very much for coming
Thanks a
on.
lot. Yeah.
It
It
was
was a
fun
wonderful thing.
conversation.
And then we'll try 2 weeks from now, we'll try to see where we should concentrate. So you can start thinking maybe next week, you can tell me, or we can work together and come up with a thing for the next, after 2 weeks.
Um, yeah, next one maybe might be genetics. We had an idea to do
Okay.
some genetic research, didn't we?
Yeah.
I don't think it'll be next week, but maybe the following week.
Seventh,
Yeah, yeah.
7th of February. No, 6th, I think. The 6th of February, probably. Yeah.
Mm. Yeah, and it really depends. Like, also, I have to keep
24, 31, 7th. Actually, it should be the 7th.
yeah, or we
I
might
think it
even
should
just
be the 7th.
might see how it goes. Yeah, because I mean, I've
It
got
sounds
other
good.
things going on, but yeah, okay, I'll leave it there. I'll close the stream.
Thank you.